This is the pre-skill video. We're going to cover two skills from algebra that you're going to need. One is solving equations, and the other is going to be simplifying square roots. So you must write all these notes down in order to have access eventually to the test. So make sure you're taking the notes, writing everything down that I do, and then you'll work on the worksheets when you're done. So our first pre-skill that we're going to cover is just some solving equations, which I'm sure most of you are pretty well equipped to do. So we're just going to do a couple and call that a day. So our goal in this one is going to be to solve for b. I've got some issues with b. First of all, it's trapped in some parentheses. It's also located on both sides of the equation, and I'm going to have to deal with that. I also have b's kind of scattered around everywhere. So we're going to tackle all three of those issues. The first thing we're going to do is tackle the fact that I've got b locked in a set of parentheses, and in order for me to solve for it, I need to get it out. So we always get rid of our parentheses first. So I'm going to leave the left-hand side intact. And then I'm going to distribute or multiply the negative 8 into the parentheses. Negative 8 times b is negative 8b. Negative 8 times negative 6 is a positive 48. A negative times a negative is a positive. So I'll have plus 48 plus the 6b that's hanging on at the end of that side. The next issue that I have, because my goal when I'm done, I want to get b equals. I want to consolidate b all on the left-hand side of the equation and have b equals. So I've got negative 8b plus 6b on the right-hand side. So what I'm going to do is, again, I'm still going to leave the left side intact. There's nothing I can do with it. I can't add them up over there on the left because they're not like terms. So I just have to leave negative 5b plus 24 hanging around for a while. But negative 8 up 6 would leave me negative 2 of those. So I have negative 2b over there plus 48. Now, you have an option, and it's up to you. I need to get the b's on one side of the equation. Some teachers will say just always get it on the left-hand side, so when you're done, you'll have b equals. And some kids like that. Some teachers will say always move the smaller one because then you can avoid negatives. So that's up to you. Honestly, it doesn't matter to me which way you do it, especially because we're not going to be dealing with any inequalities or anything. So I'm just going to move these over to this side. Then what I've got over here is they're going to disappear on the right-hand side, so I won't have the b hanging out on both sides of the equation. I'm just going to have 48 left over here on the right. And then on the left, I have a negative 5 going up 2, which leads a negative 3b plus 24. Now I have a two-step equation that I can easily unwrap and solve for b. In order for me to solve for b, I need to get rid of the 24. It's a plus 24, so I subtract it. Write that a little neater. Let's go travel up here. So on the left-hand side, I have a negative 3b. 24 is gone. And I end up with 48 minus 24, which is just 24 over on the right. To undo that negative 3, I don't add it because it's not b minus 3. It's negative 3 times b, and we do the opposite operation. The opposite of multiplication is division, and I get b is equal to negative 8. So the first one is done. The next one we're going to solve over here. I'm going to, again, untrap the k from the parentheses. The left-hand side I'm not going to mess with. I'll have negative 6 times k. Then I'll have a negative 6 times a negative 7, which is a positive 42. Then I'm going to distribute this 6 in as well. I'm going to have a positive 6 times k, which is a positive 6k. I'm going to have a positive 6 times positive 5, which is a positive 30. So I tackled my parenthesis issue. And again, my goal is to solve for k, but I've got it in two places, but it's on the same side of the equation. So I can combine these like terms. And I have negative 6 plus 6k is 0k. 0 times anything is just 0. So I end up with 0 out of those, but I still have the 42 plus 30 that can combine, and I get 72. Well, this seems kind of weird because what I'm trying to do is solve for k, and k disappeared, and I ended up with this garbage statement that 73 has to equal 72. Well, that never happens. What that means is this equation has no solutions. There's no k that's ever going to result in me plugging this in and getting 73 equal to 72. So we say no solution. That's going to happen once on your worksheet. Just so you know, there's going to be one of them where the k disappears and you get a garbage statement. However, if the k disappears and you get a true statement, so suppose I was doing, trying to think of one. Well, you'll find it on your worksheet. There's going to be another one where the variable disappears and you end up with like 5 equals 5. I'm just making that up. And what that means is what values of x will result in 5 equaling 5? And that happens all the time. So you would say that there's an infinite amount of solutions, or many solutions would be fine. So our first task, or our first pre-skill, was solving equations. The next thing we're going to work on is simplifying square roots. Just like fractions can be simplified, like I can take 12/18 and I could say, oh, I'm going to divide out a 6 out of the top and a 6 out of the bottom, and we get this fraction that's equivalent to this one, but it looks very different, and we say this one is simpler or simplified. Square roots have the same issues. Some of them can be simplified. Some of them can't. Well, same with fractions. I can't simplify that. It doesn't shrink down. So some of our roots can shrink down and some can't. And the key to figuring out if a root can simplify and how to simplify it is knowing your perfect squares. So our perfect squares are 1 times 1, which is never helpful, so we're going to cross that off, but it's technically considered a perfect square. 2 times 2, 3 times 3, 3 squared, 4 times 4, 4 squared, 5 times 5, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, and I could play this game forever because there's an infinite amount of perfect squares. So I'm just going to go dot, dot, dot. Perfect squares in the world of roots are your friends because they're the only numbers that you know exactly what the square root is. If I said, what's the square root of 4? And don't write this down. I'm going to go to green color, and let's not write down green in your notes. But if I said, what's the square root of 4? You'd say 2, 3, 4, 5, etc. These numbers are the only ones I know the roots of. Any number in between them, like between 9 and 16 is the number 10, I don't know its root. It goes on forever, it never repeats. It's called an irrational number. If someone were to ask you what's the square root of 10, you would say, I have no idea. I could give you an estimate because I could go to my calculator, take the root, and round my decimal, but really nobody knows what the square root of 10 is because it never ends. But some numbers, and root 10 doesn't simplify either, by the way, it's just done. But some numbers that live in between these, like in here is a root 8. Although nobody knows what root 8 is, it's also a decimal that goes on forever and it never repeats. It can be simplified. And the key to figuring out whether you can simplify it or not is if it has one of these perfect squares living in it or as a factor of it. So I said root 10 does not simplify, and the reason is the only things that go into 10 are 2 and 5. And 1 and 10, but that's not helpful. And 2 and 5 are not in this list. So the only thing I could do is break this into root 2 times root 5, but what I've done is taken one root I don't know and I've broken it into two I don't know, and that's not helpful. My goal is to break it into one that I know. So really the guts of it is I am searching for a perfect square living in here. So when I think of the things that go into 24, I think 2 times 12. Not helpful. Neither one is in this list. 3 times 8. Not helpful. Neither one is in this list. 4 times 6. Very helpful because 4 is in this list. So I say the square root of 24 is equal to 24 is 4 times 6. So we say it's root 4. And roots, you can either write it like that or you can write it like this. They're equivalent. So I know the square root of 4 is 2, right? So 2 can pop out of the root. I don't know the square root of 6, so it stays in the root, or we say it stays in as the radicand, but you don't need to know that. So this square root of 24 and 2 root 2 are the exact same number. If you did them both on your calculator, they'd give you the exact same decimal. Just like up here with these fractions, when I simplified it, I didn't change its value. This is on a calculator 0.6 repeated. 2/3 is also 0.6 repeated. I've just simplified it. So let's do the square root of 75. Is there a perfect square living in 75? And if so, I'm going to break it up. So what I do is I go search my pool here. Oh, there, I know that goes into 75. It goes in 3 times. So I break this into the one I know and the one I don't know. 25 times 3 is 75. So this I know is 5. This I don't know. So my answer is the 5 will pop out of the root and the 3 stays under the root. So again, your goal is to find the perfect square hiding in your root. But lastly, before I quit, you really want to make sure you find the biggest perfect square or it's not done and you have to keep going. Again, I'm going to reference the issue of fractions. On the previous page, we discussed 12/18, and I told you I could divide a 6 out of both and get 2/3. Well, suppose little Billy Bob says, oh, I'm going to take a 2 out. And he says, this is really 6 over 9. Billy is not wrong. He's just not done, silly Billy. I still can go farther. There's still a 3 on the top and there's still a 3 on the bottom. So if you miss the biggest perfect square hiding in the number, doesn't mean you're going to get it wrong. It means you might have to run through the process more than once. So it is to your benefit to find the biggest perfect square factor. So let's discuss that. I'm going to put one up here that has a couple perfect squares living in it, and I'm going to do it 2 ways. So let's suppose somebody did what I said and tried to find the biggest perfect square hiding in root 32. The quickest way to find the biggest one, I'm going to go back and reference our perfect squares. Instead of just going, oh, 4's in there, let's try to find the biggest thing. And again, we're looking at 32. The easiest thing to do is to cut it in half and start looking this way. So half of 32 is 16. So I'm going to put a little boundary up here and look that way. Does 16 go into 32? Yes, twice. So that is going to be the biggest, and I would only have to do this process one time. I'd say it's root 16, root 2, which is 4, root 2. And make sure you don't say, oh, 4's can go farther, it's 2. No, it's not. 4 is never 2. That is ridiculous. The square root of 4 is 2, but the number itself would never be 2. So that's done because I found the biggest. But let's suppose you didn't. So let's suppose somebody said, you know what, I'm just going to find anything. And some people do that with fractions too. They'll say, okay, if I'm working with 24/36, I'm not going to bother finding the biggest. I'm just going to knock out a 2, I'm going to knock out a 2 again, I'm going to knock out a 3, and I'll just do it in multiple steps. I'm not going to spend my time finding the biggest one. That's just fine with roots as well. However, if you're going to do that, all right, so right back to my root 32. If you say, I'm just going to dive in and find any perfect square in there, and you say, I'm going to do 4. I'd say that's not wrong. And I'd say this isn't wrong either. It's just not done. And here's why. 8 is still undercooked. It still has a perfect square hiding in it. 8 still has 4 embedded in it. So I have to take this one more step and change that root 4 to 2. 2 times 2 is 4. And notice I didn't get the wrong answer. I just had to take 2 stabs at it. But what is wrong is leaving this, because here's why. In fraction world, it would be like saying 10/20ths simplifies down to 5/10. It is true that those are equal, so technically that's not a false statement. But we know that the biggest thing I could have taken out of here is a 10. So the answer that we're looking for when it says simplify is 1/2. So you have to make sure that if you're not going to spend the time finding the biggest perfect square, that you recognize that they can go farther. The biggest one for this is, I'll show you. And you don't need to write this on your notes, but the square root of 72 kids do wrong a lot because they immediately go to 9 and they go, oh, that's root 9 root 8. That's not false. That's totally true. But then I get 3 root 8. And this still isn't done, and I'd have to go farther. So it might be worth your time to find the biggest perfect square that goes in here. And recognizing that 36 goes into 72 twice. Then I only need to have one step. So just make sure you're done. When I check your worksheet, I'm going to be particularly focusing on those that have multiple square roots and making sure that you take it all the way to the end. And then I'm going to throw in a little bit of vocabulary here before the next chunk of notes. So a little bit of vocabulary to prep you for some basics in geometry. This is super easy stuff, but it's the difference between a line segment, array, and a line, and how you name them. So to name a line segment, all you do is list the endpoints and you put a bar over the top. The endpoints you can list in either order, but you must put the bar over the top because without it, it means how long it is. When I write AB, it really means how long it is from here to here. And if it's 7, AB is actually 7. With the line over it, it's the picture of the segment. So array, oh, that's not a nice letter. Let's make it maybe an X and a B. Array is a little bit more restricting because you have to have the first letter be that initial point or the shout out point, and then you have to send it through any other point on the array and put array over the top of it in that direction. So make sure that this gets listed first. A line can be named, I'm going to put 3 points on here, with any points on it in either order. So I can name that thing line AB, but I have to put the symbol for a line over it. Or I could call it line CA, but I have to put the line symbol over it. Or I could say BC. That's all good. You can use any 2 points to name it. So the ray is the most restrictive. However, if there were another point in here, I could also call that ray X and send it forever through C. So either as long as you get that endpoint and send it forever in the other direction, that's legal. So because this is the first set of notes and I want to get you used to the procedure, you're going to stop right now, okay? You are going to stop and you're going to work on the worksheets P1 and P2. When you're done with those, you're going to show them to me and I am either going to okay it with my signature or a stamp or something, and then you can move on to the next set of notes. If you don't have these notes to show me and you've just gone right to the worksheet, I won't sign it, and you're never going to get the tests until I sign them, and you do not get credit for this course unless you pass each test. And I'm not going to give you the test without notes and worksheets. So once you get used to the system, you'll fly on through. Have a good one. Peace out, Girl Scout.